Uh, this is your Reynolds apparatus, in which this is your reservoir from which we will collect the tank and we will send that water into our pipeline. This is the reservoir and this is your pipeline and this is your collecting tank and this is a motor. So before starting our experiment we have to observe that the tank is full of water and then turn on your motor. Once if you turn on your motor, adjust your flow rate by turning this valve. So we can adjust our flow rate by turning this valve and you will know the level of water from the scale. So once you adjust your water, once you turn this to 2 rounds, first we will start from lower flow rates and then we will move on to higher flow rates. So for that what we will do is, we will turn on 2 rounds of this valve and then wait for 2 minutes. The water will flow through this pipeline and the water which is flowing through the pipeline is collected in the collecting tank. In this if you observe, the pipeline is given with the transparent material because to observe the flow rate. So the main aim of our experiment is to know the different flow regimes with the increasing flow rate. So as we all know that we have 3 different flow regimes, that is the laminar flow, turbulent flow and laminar flow, turbulent flow and transition flow. So for that I will start experimenting with the lower flow rate. Once this is a turn, 2 turns, we can see this is the pipe, this is the arrangement for the tracer. So in this arrangement, in this pipeline we have a small needle like thing to send the tracer to it. So once at the lower flow rate, when I am sending the water to it and if I open the tracer valve, small amount of a tracer, that is a color, will be released into it. So at lower flow rates what will happen is, this tracer will not mix with the liquid, that our liquid is a water. So both will flow as a different flow rates or separate flow rates. You can see two different fluids are flowing inside this pipeline. So that type of flow pattern is called laminar flow pattern. If I keep on increasing this, so this is a one set of experiment. To calculate the velocity, what you have to do is, once you have adjusted your flow and you will get that water at this collecting tank. To know the flow rate, how much amount of water is flowing through it, we don't know because we don't have rotometer facility here. If you have a rotometer facility, then you can directly adjust your flow rate. But we don't have that, so we have to calculate our flow rate based on the volumetric flow rate method. So once you have arranged your flow rate and then wait for 5 to 10 minutes and in this collecting tank we will collect some water. So after that you measure the time required for 10 centimeter rise. So from the time and the volume of water collected, you can calculate the volumetric flow rate. So once the volumetric flow rate is calculated, based on the volumetric flow rate, we can calculate the velocity. So once we know the velocity, we can calculate Reynolds number required for the Reynolds number of this particular flow. Based on the Reynolds number, we can segregate our flow patterns into 3 types: laminar, transition and turbulent regions. So once one set of experiment is completed, then we will increase the flow rate to the next higher level and we will repeat the same experiment with the visual observation also. So we have to observe visually how this water is flowing. So at the transition, the tracer will submerge into the our water. So once it is a transition turbulent flow, what will happen? We can observe that both the liquids are dispersed. So one liquid is dispersed in the other. So that is called turbulent flow rate. This is from the visual observation, and by calculating the volumetric flow rate also, we can calculate the Reynolds number. Based on Reynolds number, if Reynolds number is less than 2100, we can call it as a laminar flow. If it is in between 2100 to 4000, we segregate it as a turbulent flow. And it is above 4000, then we will call it as a turbulent flow. So till the higher flow rate. So when we get a higher flow rate, we have to open this valve completely, then we get the higher flow rate. So at higher flow rate, we get our turbulent flow.